Part 14, CAN bus error detection techniques. In this tutorial we are going to see about what are the error detection techniques that make simple and unique that creates a significance of using CAN protocol. See, we have 5 different ways of detecting errors in CAN protocols. So only these are all the 5 ways of detecting errors, no more in this. Apart from that, we have the active passive bus of it's not comes under this category. So that is of different category. But in this, the CAN protocol defines only the 5 ways of detecting errors. That is bit monitoring, bit stuffing, frame check, acknowledgement check, and CRC, that is cyclic redundancy check. In this, the first two and last three has been categorized into two forms. That is, the first two will works on the bit level, and the three or works at the message level. So that is the bit monitoring and bit stuffing can be detect the errors while transmitting the bits. That is the while transmitting the signals as a bit. So if there is any problem with the bits, then the bit monitoring and bit stuffing broadcast the particular error. Whereas once the bit has been successfully done, then if we goes to the message level, then frame check, acknowledgement check, and cyclic redundancy check will comes into picture. Let's see one by one in detail. Bit monitoring. So what is bit monitoring? See, each transmitter on the CAN bus, that is CAN bus monitor, which monitors the transmitted signal level. If the bit level actually read differs from one transmitter, a bit error is signal. Say for example, um, if I am transmitting you something, say I am transmitting you 1111 441 I am transmitting, but the one bit has been converted as a zero because of some error distortion or because of some corrupted signal, then the bit error will be signaled. So the bit error, the flag will be will automatically enabled, and which broadcast that there is a problem with the bit error, that is a problem with the particular bit. So that is what bit monitoring is. So here no bit error is raised during the arbitration process, whereas in arbitration there will be no bit process, bit monitoring. Whereas while transmitting the signal, there will be the bit transmitting, that is a bit monitoring that will check on every transmitting messages or a signals. So here we have the clear understanding with the pictorial representation. So as we are started with SOF and ended with EOF, there is end of frame. See, the bit monitoring has been starting from here to here. So here includes that SOF identifier, then RTR, ID, DLC, data fields, CRC, DEL, then ACK, again DEL, AOF. So this all the bit monitoring will be checked in terms of the sender, because I'm a transmitter. So this is also one thing that you have to understand, that bit monitoring will relies only for the sender and not for the receiver, whereas stuff check, CRC, then form check. So these three will comes under the receiver, whereas the acknowledgement and bit monitoring will comes under the sender, that is transmitter. Okay, so this is what the bit monitoring all about. So if you again once again if you see this, see each transmitter on the CAN bus that will transmit a signal level. If the bit level actually differs from one transmitter, then it will signal as a error. See, for example, if we are sending, as I said, we are sending four ones, but in all the field, the if the receiving gets any one bit has been different, then it will signal as a error. That is a main work of the bit monitoring. You can get a more and more paragraph in this, but this is a very simple way to understand what is bit monitoring. The next is bit stuffing. Yes, here we have bit stuffing is the second one. So here the if you comes under this, the original data has been sent is 110111111. So here we have 7 ones, then 00. See, but the data stream, how the data will flow: 110, then 11111. So here we have 5 ones, then the sixth bit will be always, that is what the bit stuff. So the fifth bit, it will be complementary bit that will be given by the CAN transmitter, that is the protocol. So the 0 will be injected here, then again this one will continue here, then this one will continue with here, then 00. So here again start of terminator, that is the terminating message. So 1111 6 ones. So in this way the bit stuffing will work. So the bit stuffing is, it will just check the, if there is any consecutive 6 bits, then it will just stop with the fifth bit, then it will inject the opposite polarity there. So for example, if you have here 6 bits of 0, then the sixth 5 bits of 0 will be streamed, then the sixth will be one, the opposite polarity will comes automatically. So that is what the bit stuffing, so that it will not while retrieving the original data, this complementary bit will be disabled, so it will ignore, and whereas the original data will be delivered. So this is what the bit stuffing is. In simple terms, when 5 consecutive bits of the same level has been transmitted by a node, it will add a sixth bit of the opposite level as a complementary to the outgoing bit stream. So this is what I said. The receiver will remove this extra bit. So in while in transmitting it will happen, but when receiver the receiver and it will remove the sixth extra bit. This is done to avoid the excessive DC components on the bus. So whereas we have seen in the last tutorial that the 120 ohm resistance, that is the DC components on the bus, so that was also has been removed, but it also gives the receivers an extra opportunity to detect the errors. So this is the main purpose of this, is to get the receiver to detect the extra errors. If more than 5 consecutive bits of the same level occur on the bus, then stuff error is signal. So stuff error will signal. So this is what the stuff error is being done at the bit level. So this is a very simple concept and example of the bit stuffing. Whereas the next will be frame check. Yes, here we have, as we mentioned here, the bit monitoring done, then bit stuffing, then we go to the frame check. So these three comes under the message level, whereas the bit level has been done, then message level. So the can message have a fixed format. Yes, of course we are watching from the beginning that can have the set of standard, it has to follow the fixed format. That is exactly that standard defines what levels must occur and when to occur. Yeah, this is what are the sequence has to happen and when to happen. That also the actually the can protocol deals. Whereas frame check is significantly help a lot to achieving these criteria. Say for example, CRC delimiter, acknowledgement delimiter, a of end of frame, and also the intermission, but there are some extra special error checking rules for that. So this is a one-line statement for the frame check. If a CAN controller detects an invalid value in one of these fields, a form error is signaled. That is, say for example, 1 second. So yeah, so if any CRC error or CRC delimiter or acknowledgement delimiter or end of frame, so in this any error has been occurred, then that will be signaled as a form error. Okay, so this is a very there is no more no more explanation is required for this. Say for example, yeah, CRC that we'll see in the upcoming slides, you'll understand what is how the CRC will work. So acknowledgement delimiter will works like if I'm transmitting you something. Say for example, if I am sending you one, once you receive the one as one successfully, then you have to make it to 0. So that is the acknowledgement acknowledgement. Whereas if you are not making a 0, whereas it is keep on sending one even after certain time, then it will be a acknowledgement error. So that is what the acknowledgement error deals with. So if any error comes, then form error will be signaled. This is what check in, it will check in the frame in the frame wise. So that the CRC you'll see in the next slide, so that you'll understand. Again, acknowledgement check. So this is acknowledgement delimiter. Say for example, all nodes on the bus that is correctly receives a message here. That's what I said. If I'm sending you one, if you receive successfully, regardless of the interest its contents or not, as expected dominant level, as so it's called acknowledgement sort is in the message. So that's what I said. So if you receive a message, then it will make it as a 0 or 1. So it is opposite. So it is what acknowledgement check will happen. The transmitter will transmit a receive level. If the transmitter can't detect a dominant level in the acknowledgement slot, then acknowledgement error is signal. So that's what I said. If I am transmit you the receive level, if the transmitter can't detect the dominant level, then it will be an error. So simple. If I send you one, you have to, once you receive, you have to make it to 0, so that I can understand that you received it. If I'm sending you 0, you have to make it to 1, so that again the transmitter, I will understand that your receiver has received and converted to the opposite polarity. If not, then it will be make it as a acknowledgement error. Then CRC, it's a very interesting error check. So it's a cyclic redundancy check. Each message features 15-bit CRC, and any node that detects a different CRC in the message, that is what is calculated itself, will signal a CRC error. So let's see, let's understand how it will work. So here we have the data 11010000. So there is triple zero we have given, and whereas while dividing, if you get, so it's just a common division concept, that if you receive that remainder as a 001, then it is a error. So it should be errorless. Say for example, here the data is 1001110. So here we have the factor of 1011, then it is coming as a remainder as 0, that means there is no error. So this is what the CRC will check. So CRC will check the with the data whether the remainder is become 1, then it will be error. It will throw the CRC error. If no, then it will pass the the frame, that's it, will pass to the message level. So this is what the very simple understanding about the error detection technique. And the upcoming tutorials, we'll see about the bus off. It will be a continuity of the error. If I have not merged this bus off with the previous tutorial, then you'll get confused that bus off may also one of the error checking technique, but it is not. Bus off is the different concept. The bus off, the error detection technique will comes under only 5 steps that what we have seen. So in upcoming tutorial we'll see about the bus off error. Until then, just watch once or twice, so that you can come to know what exactly the CAN protocol is. At the end of this playlist, yes, you can definitely comes can get a clear idea on the CAN protocol. So stay tuned and catch you in upcoming tutorial.